if I'm solving B, I'm hoping you can predict that it's not going to slide as high, because on top of gravity, I now also have force of friction, which is that away. Normal, Fn, mg, and force of friction, which I will have to calculate this time. So the height is going to be slightly less than before because we're going to be robbed of mechanical energy due to friction. Again, I'm going to solve it two ways. You pick the one you like. Work net is going to be work of gravity plus work of friction. Let's find force of friction real quick. Force of friction is going to be 0.35 times mass times 9.8 times cosine of 30 degrees, this right here being normal force. So plugging that in, keeping m. Again, if you are allergic to keeping m, go ahead and make up. It's 1 kilogram, 2.97 m's, keeping m, newtons. Then work of friction is going to be 297 m times x, cosine of 180, that's going to be negative 297 mx. Then work of gravity, we already calculated it before. Work of gravity being mg times x, cosine of 120, work of friction being negative 297 mx, putting them together. That was, remember, what was it before? 4.9 mx, and negative 297 mx gets me negative 787 mx. That is going to be the change in kinetic energy. Kinetic energy, remember, was 0. Change in kinetic energy was 0 minus initial energy being m25 over 2. So negative 12.5 m. And that gets me to net work being this being change in kinetic energy. I set them equal to each other. So then x is going to be 12.5 negative divided by negative 787. Negatives cancels, masses cancel, and that becomes just 12.5 divided by 787, 1.6 meters. This is the answer, and it's less than before. Before, it climbed to 2.6 meters. Now, only 1.6 meters. Now I'm going to resolve this question again, not through network, but through initial potential energy, final potential energy, and work of friction. But I'm not going to recalculate the work of friction. So I already know work of friction is negative 297 m times x. Potential energy initial was 0. Kinetic energy initial was 12.5 masses. Then potential energy initial, kinetic energy initial plus work of friction. So 12.5 masses plus negative 2.97 mx should be equal to final potential energy, which is mg times h final. So this is 9.8 times m times h final. And remember, what is h final? That is going to be x times sine of 30. Sine of 30 is 1/2. So it's going to be x divided by 2. So then I can do 12.5 m minus 297 mx equals 9.8 m times 1/2. So 12.5 m minus 297 mx equals 4.9 mx. Put these on the same side. 12.5 equals, cancel masses while you're at it, equals 787 x. X equals 12.5 divided by 787. What do you know? 1.6 meters. So this was the solution through energy plus work of friction equals final energy. Initial energy plus work of friction equals final energy, and it gets you the same answer. You will have a lab in which you will start with initial elastic energy, and your car is going to climb upwards, and you're going to have to figure out things. So this is actually helpful for you to be able to do that other lab on your own. So thank you for watching, and thank you for following along.